Good morning to Dr. Baharudin. Today we are going to present for our assignment 3. Our group member consists of Tan Pei Yi, Lee Rui Hang, Tan Xiaojia, Lim Ki Natalie, and also Ng Zi Heng. I am Lim Ki Natalie, and I will be presenting for the topic of basic calculus, and subtopic is linear equation. The linear form can be represented in fx equals to mx plus c, and later we let the fx equals to y becomes mx plus c, and it is an equation of the straight line with the slope of m and y-intercept c. The slope formula is m equals to y2 minus y1 over x2 minus x1, and it can be converted into the following formula. Now let's try on a question. For example 1, find an equation of the line passing through 3, 7 and 2, 4 coordinates. First, we find on the m first. In here, the m is 3, and later we substitute the 3 into the equation. And we found out the equation is y equals to 3x minus 2. There are two types of line, which is parallel and perpendicular. For example 2, state the equation that is perpendicular to the line y equals to 2x plus 12. First, we use the formula of perpendicular and we find out the slope of the line. And then later, we create our own equation that is perpendicular. Intercepts. X-intercepts is the point where the graph intersects the x-axis. And in order to find x-intercepts, we substitute y equals to 0 into the equation. While y-intercepts is the point where the graph intersects the y-axis. To find y-intercepts, we substitute x equals to 0 into the equation. Example 3. To find x-intercept, we substitute y equals to 0 into the equation, and we found our x-intercepts is -2, 0, 7, 0. To find y-intercept, we substitute x equals to 0 into the equation, and we found our y-intercepts is 0, -1. Example 4. Sketch a graph. To sketch a graph, we first find out the slope first, and in this equation, the slope is 3. And later, by using the same way, we found out the x-intercept and y-intercepts. After finding out all the points, because of the slope of this equation is positive 3, thus the graph is inclined up and to the right. And the x-intercepts is 2 over 3, 0, while the y-intercepts is 0, -2. Middle point between two coordinates on a straight line. The formula is given by x2 plus x1 over 2, y2 plus y1 over 2. For example 5, find the middle point between A and B. By substituting the number into the formula, we get our middle point, which is 4, 7. Distance between 2 points. The formula is square root of x1 minus x2 squared plus y1 minus y2 squared. For example 6, to find out the distance between P and Q, we first substituting the number into the formula, and then later we get our answer as the square root of 20. That's all from me. Now let's pass to the next presenter. Thank you.
Hey guys, my name is Tan Xiaojia. Now I want to present topic for basic calculus. The subtopic is functions. Function means each input number exactly one output number. The input numbers is the rule applies is called the domain of the function. The output number is called the range. Function also is a variable represents input numbers for a function is called an independent variable. Output numbers is called dependent variable because it depends on the value of independent variable. For an example, y equal to x plus 2 defines y as a function of x. Input x exactly 1, output x plus 2, which is y. So if x equal to 1, then y equal to 3. Independent variable is x and the dependent variable is y. Gx, which is g of x, means the output number in the range of g that corresponds to the input number x in the domain. For an example, to find f3, which is the output corresponding to the input 3, so replace each x in fx equal to x plus 2 by 3, so is f3 equal to 3 plus 2 equal to 5. Domain of a function. It consists of all real numbers for the rule of the function makes sense and it gives function values that are real numbers. For example, hx equal to 1 divided by x minus 6. So any real number can be used for x except 6 because the denominator is 0 when x is 6. Thus, the domain h is understood to be all real numbers except 6. That's all from me. Now I will pass it to my group mate. Thank you.
Hi everyone, I'm Ng Ziheng, and now I will presenting the part of application of differentiation. In this part, we can know how to determine minimum and maximum value and know how to find critical points. In application of differentiation, we can know how to find minimum and maximum value. And we can know how to find a critical point and determine whether the critical point is minimum or maximum value for the function fx and fxy. Minimum or maximum value used to find minimum or maximum area of a location or shape and occurs when dy over dx equal to 0. We must know the formula of location or shape before finding its minimum or maximum value. To determine minimum or maximum value, we must find the second order derivative first. The value is minimum if the second order derivative is positive and maximum if the second order derivative is negative. Let me give an example how to find the largest volume of the box. The first step is we need to know the formula for volume of the box. The formula is long times wide times height, and with this formula, we can know that volume equal to 48x squared minus 4x power 3. Next, we need to do differentiation for the volume, and the differentiation for the volume is 96x minus 12x squared. Minimum and maximum value occur when dv over dx equal to 0, so we take the differentiation for volume 96x minus 12x squared equal to 0, so we can get x equal to 0 and x equal to 8. Next, we substitute x into second order derivative, that is 96 minus 24x. In this step, we can know that x equal to 0 is minimum value and x equal to 8 is maximum value. We choose x equal to 8 because we want to find the largest volume of the box. Last, we substitute x equal to 8 into volume. When x equal to 8, volume equal to 1024. So we can know that the largest volume of the box is 1024 cm3. For the one variable function fx, we need to find value of f prime x equal to 0 first, and then we just can find a critical point. After we get the critical point, we just can determine the minimum or maximum value of the critical point. For the example of fx equal to x power 3 minus 27x plus 1, we need to find the value of f prime x first. After that, we can know that the value of x equal to plus or minus 3. Then, we will substitute x equal to negative 3 and x equal to 3 into fx. So we will get the critical points negative 3, 55 and 3, negative 53. After that, we can determine minimum and maximum value using f double prime x. We can substitute x equal to 3 and x equal to negative 3 into f double prime x. So we will know critical points 3, negative 53 is minimum value and negative 3, 55 is maximum value. For the function fxy that has two variables, we need to find partial differentiation for fxy and assign each partial differentiation with 0. That means we need to forming two equations and find the value of x and y by solving the equation. Then we will get the critical point. For this example of function fxy, we need to find a partial differentiation for x and y and forming the two equations. After that, we add these two equations to get the value of x. And next, we substitute the value of x into first equation to get the value of y. So, we will get the critical point negative 1 and 1 over 2. Last, we need to find the second order derivatives for the two equations we form. And the second order derivative for the two equations is positive. So, the critical point negative 1 and 1 over 2 is minimum value. Thank you everyone. I've done my part of this group assignment, that is application of differentiation, and I will let my group members to continue the presentation.
Hi everyone, my name is Dan Pei Yi, and now I am going to present about the integration application, that is area under curve. This is the example graph. This graph is formed by one curve, that is y equals to fx, and 2 points, that is x equals to a and x equals to b. The area under a curve between 2 points is found out by doing a definite integral between the 2 points. To find the area under the curve y equals to fx between x equals to a and x equals to b, integrate y equals to fx between the limits of a and b. This area can be calculated using integration with given limits. The formula of area under the curve is integrate a to b fx dx. For an example, a question is given. The question is, calculate the area under the curve of a function fx equals to 7 minus x squared. The limit is given as x equals to -1 to 2. The solution can be solved by using the formula of area under curve, that is, integrate a to b fx dx. So that's all from me. I will pass it to the next presenter.
Hello everyone, my name is Leroy Hang. This is my metric number, and today I will talk about integration and the area between two curves. I will introduce the first formula for the area between two curves. The first formula is area equal to integrate BA, then first equation minus second equation. Then first equation is the upper function and the second equation is the lower function. Then I will give one example. The question is determine the area of the region enclosed by y equal to x squared and y equal to square root x. And firstly, we need to draw the graph, and we know what is the upper function and the lower function, and we can know a equal to integrate BA or upper function minus lower function, and we can get the answer. Now I will talk about the second formula, where is a equal to integrate dc fy minus gy dy. Then the first fy is the right function and the gy is the left function. We can know is right function minus left function. Now I also give one example for it. The question is determine the area of the region bounded by x equal to -y squared plus 10 and x equal to y minus 2 squared. And the solution is, first step, we draw the graph and we know what is the right function and the left function. Then we use right function minus left function and integrate it, we'll get the answer. Now we'll come to the conclusion, and I will talk about what our team member have done for this assignment. And firstly, the Netiara Lim already done the introduction and the linear equation. And second, the Xiaojia will talk about the function for this assignment. And for the Ziheng, he will talk about maximum or minimum value and the critical point for the differentiation part. And Pei Yi will talk about the area under curve for the integration part, and I will talk about the area between two curves and the conclusion. And I will end this video. Thank you for watching.